Okay, let's start with Numpy. Numpy is a linear algebra library which is very famous for data science. So you cannot imagine using Python without Numpy if you are doing anything related to data science right now. And why Numpy? Why don't we use just basic Python? It's because Numpy it has bindings with C libraries, so it will be very fast and it will be very much efficient for the memory if you can use it efficiently. Together with that, Numpy comes with many built-in functions that we can use directly out of the box, so we don't need to implement some of the things that we don't need, like let's say for example fast Fourier transform, convolutions, or something that is quite heavily used in data science. So to install Numpy in your Conda terminal, you have to type conda install Numpy, but almost all of the Conda variant comes with Numpy pre-installed. Numpy and pandas are very famous, so most of the Anaconda distribution already comes with Numpy and pandas pre-installed. So we can just go through this shell and then start by loading the Numpy library. So we will run this shell using shift enter. So what this shell does is it will import Numpy as any other Python library and it will rename it as np for this session. So now we can access Numpy as np further down in our notebook, and I suggest you to open this notebook side by side while going through this video, so whenever you have any confusion or whenever you are curious to try something that is not shown here, then you can do it. And if you face any issues, you can always ask us. So let's go through the basics of Numpy. First is arrays. So we already know what arrays are. So in Numpy, so let's just go through how to write an array in Numpy. So there are several ways to start a Numpy array. So let's say we already know how to create a Python list. So Python list is also an array, but now we are focused on Numpy, so we will create Numpy array. So at first, let's see, we will create a list called my list with items 1 2 3, and let's print it. It's 1 2 3 is printed, and let's check the type of the list is list. So the type function, it will check the type of the data. And to create a Numpy array from list, we have to use this syntax: np.array mylist. And if we print our list, our array, then it is of type. You can see it's printed like array 1 2 3. And if you print the type, it's the type of the Numpy array is Numpy nd array. If you want to create a matrix, then also we can create using the Python list itself. So we need to create a list like this, and then we will use the np.array my matrix. So you can see this is the Numpy matrix. So other way to create a Numpy array is using arange. So the function arange will create evenly spaced values in an array. So when we give the values, the first one is the starting value and the second one is the ending value. So it will not include the second one. So let's say if we need 10 items from 0 to 9, then we will use np.arange 0 to 10. Or if we want to skip, let's say we just need the odd numbers from 0 to 10, then we can use something like this: So we will need the numbers from 0 until 11 not included, and the step size is 2, so it will be step by 2. If we say step 1, so it will print all the numbers. Okay. And so the next one is how to create 0 and 1 matrix or 0 and 1 array. So for that we have the function or numpy method called zeros. So if we say np.zeros, it will create an array with 3 number of elements, because we mentioned 3. If we need an array of size 5, then we'll get the size. Similarly, we have the function called np.ones. Once will create an array of ones. Also, together with these things, we can also create numpy array using the command linspace. So what does linspace does is it will create evenly spaced number within the specified range. So it's similar to a range. It will create the evenly specified numbers. So let's say we want the numbers from 0 to 10, but how many numbers? We only need 3 numbers. Or let's say if you want 5 numbers that are evenly spaced from 0 to 10, so we will get 5 numbers. And be careful, it will include both the numbers 0 and 10. And if we need more numbers, we can also define like this. And next one is how to create an identity matrix. I think all of you have studied in linear algebra what is an identity matrix. So to create an identity matrix in NumPy, it's very easy. We will just use the method EYE. So when we use the NumPy method I and give the dimension, it will create an array of dimension that we gave. And similarly, if we want to create some random arrays, we can use the command random. So you can just get from np.random randan 2. So this means we will only take 2 or 3. Okay, 3 random values. Or else we can also give the size of the matrix that we need, if we need matrix. So let's say I need 4 into 3 matrix with random values already inserted. So this will return a random array with the number of values included. And similarly, random and if you need to get only a certain random number within a range, let's say you want to generate a random number between 0 to 100, we can use the function np.random rand integer between 1 to 100. So in this case also it will include the first one and exclude the last one in the range. And if you need more than one random numbers within the range, we will add another parameter n, which gives the number of random numbers. So if we run this command, it will return 10 random numbers within 1 to 100. So now let's go through some of the attributes and methods of NumPy array. So to go through this, we will create 2 arrays. One is my array, which contains the numbers from 0 to 24, and second one is a random array, which contains the random numbers from 0 to 50 and 10 number of random numbers from 0 to 50. My array and my R array. So the first method that we want to learn is reshape. So if you want to change the shape of your matrix, let's say right now my array, the shape of my array is, let's check what is the shape of my array. So we can check using my array dot shape. So it shows the shape of our array is 25 comma nothing. That means it is 25 into 1 matrix. So if we want to reshape it into 5 into 5 matrix, we can just type my array dot reshape 5 into 5. So it will transform into 5 into 5 matrix. Transfer this array into 5 into 5 matrix. But we have to be careful here is when we want to reshape, we have to know the size of the array. So right now we had the array, my array of size 25, and we wanted to reshape it into the array into the matrix of 5 into 5. So 25 objects can be placed into 5 into 5 matrix, but it cannot be transformed into 3 into 4 matrix. Let's see what we will see. So in these cases we will see the error like this. So cannot reshape array of size 25 into this shape. So you need to know the size of the array before you want to reshape, and if you see this kind of error, then you know what is wrong. And let's go through a few other methods. So first method is max. So what this method does is it will return the maximum value from that array. Let's see, my random array has these values, and when we use the method max, it will return the maximum value from that. And to get the index of the maximum value, we have another function called argmax. So what this function does is this will return the index of this array. Let's go and check. So it says 41 is the maximum number. So 41 is the maximum number. So argmax returns 5. 5 is the index of the highest value. So 0, 1, 2, 3, 4, 5. So that's why it returns 5. And again, we can check the shape of the array using shape attribute. So we have to be careful here. So the shape is an attribute, but argmax is a method. So method always follows with parenthesis, but shape will not have parenthesis. If we put shape with parenthesis, then we get issues something like this: tuple object is not callable. So we just use shape, or we can reshape and then ask for the shape. Reshape the array and ask for the shape. So if we want to check the type of data that is inside the array, we will use dtype. So if we use dtype, it will show the type of array inside the array. So let's see, in this example we are going to create a new array with the values 0.4 and 0.5. The type of these values are float, so it should return dtype float. So this returns float 64. Okay, so let's go through some of the indexing and selection in Numpy. So let's print the value in my array at first. If we want to select the individual item, we will select it like we used to do in Python list. So if we give the index, it will return the value inside an index. So the value at index 3 is 3, so it will give 3. Or else if we want to return the values within a range, so let's say we will say I want the values from index 1 to index 5. So this will not include the index 5. So it will print from index 1 to index 4 and return. If you want to get the values, we have to use this operator. And for slicing, so let's say I just want to get the elements from starting from index 4 until the end of the array. That means we can use 4 and just the colon sign without anything in the second part. Or let's say we want all the items from the start until the index 4. It will give only the items before index 4. So next important concept in NumPy is broadcasting. So broadcasting means how NumPy treats arrays of different shape when they are together. Let's say we will define an array of shape 4 into 3. Let's print it. So this is our array A of shape 4 into 3, and then we will define another array of size 1 into 3, or we say just size 3. And if we add these two array, you can see it will add the value of B into all the elements of, let's say, all the rows of array A. So how is this possible? So this is possible because of broadcasting. So NumPy has this unique feature called broadcasting. What they do is, let's see in this image, we have an array called A of size 4 into 3 defined like this, and B is only defined 0, 1, 2. It only has one row. But when we add two arrays and then there is a mismatch in size, let's see, the size of A is 4 into 3, but the size of B is 1 into 3. So what it does is it will stretch, or it will broadcast the values of B so that it will match the size of A, and then it will return the result. So this is how it works. Also, let's check one more feature within the broadcast. So this is our array, and then we will set the values from index 0 to index 4 as 100. Let's see, we set the values from index 0 to index 4 as 100, and then we will make a slice of an array. So to make a slice of an array, we will create a new variable and then just create the slice. Let's print the slice. Okay, so the slice only has the values from index 4 to 7. So that means it has the values 10, 5 and 6. Let's try to change the value inside the slice. So this is our slice of my array is the slice, and let's try to change this 5 to 500. Okay, so when we see, it changed the slice of an array. So you see, now previously it was 100, 5 and 6, now it is 100, 500 and 6. But one thing we need to be careful here is, what Python does while slicing is, it will not create a new array, but it will only create a view of the original array. That means slice of my array is not an array in itself, but it is only showing the values within 4 to 7. How we can verify that one is like, okay, we changed slice of array to have 500 in the index 1, which is index 5 in the original array. So now let's check the original array. See, so the original array is also changed. So this, why this happens is because of broadcasting. What NumPy does is, whenever we slice some array, it will not copy the values into new variable, but it will only give the view of the original array. So this is how it will save the memory. So that means when we, let's say, if we want to do some operation, and while running the operations, a same array might be copied 100 times. So NumPy wants to reduce the memory usage that time. So instead of copying same thing for 100 times, it will only give the view of the original array to all those 100 things, 100 variables. So they will not occupy any memory in our storage. But in some cases we really want to use the in some cases we really want to copy those numbers into the variable. So for those cases we will have to use dot copy. So when we use dot copy for the same thing, let's see how it will work. So now we will try to change this 500 back to 500. So in slice of my array it's changed to 5. Let's go in and see in my array. So in my array it is still 500. That means now slice of my array is an array of its own. It is not the view of my array, but it is all the values are already copied into its own. So let's discuss about the 2D arrays, how we can access the values in 2D array. Let's go and see our array A, our matrix A. So when we select when we only give one dimension, so it will only select the first row, the row with index 1. And if we want to select an individual item, let's say we want to select the individual item, this 10, that means we have to give both the dimensions. So the index 1 in row and in column index 0, that means it will display 10. Or if we want to mention together just by separating with a comma, it's also same. It's same like running with A10 or 1,0 is the same. And let's go through the slicing. We already know how to slice an array, so let's go through 2D slicing. So for 2D slicing, let's create a 2D array and how we can slice. So you can see in this command we have said we need everything from starting until index 2 for row, and for column everything starting at index 1 until the end. So if you see the example here, our array 2D has two rows, 2 3 4 and 5 4 7. So we have selected the rows 0 and 1, so 2 is not included, so it will return 2 rows, 0 with index 0 and with index 1. And for the column, we have said include the column with index 1 and whatever is its last limit, so it will display only this 3 4 and 4 7. Similarly, you can see how it works for other values. Now let's create a new array with values from 1 to 5. We can use the comparison operators on the Numpy array directly. Let's see, we have an array ranging from 1 to 5, and if we say array is greater than equals to 5, it will return the new array with boolean values that satisfies the condition. So it will apply this condition to every element in that array and return the boolean. So let's see, 1 is greater than equals to 4, false, 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 and 4 is greater than or equals to 4, it's true, so it will return true, true. We can also save this new array as boolean array and then just display. Then we can only select the items that are true using this command. So this is all for the basics of Numpy. You can go through the exercise and try to complete all the exercise and upload it to Google Forms.